In the previous videos, we have already learned how to simplify complicated circuits by using the concept of series and parallel connections. So, however, there are some complicated networks of resistances that cannot be easily um, simplified using the said concept. So, for example, in this bridge network shown, we can observe that the resistances R3 is not necessarily in series or in parallel with R4 and R6. So there is no direct series or parallel connection. So in this regard, we will be invoking a new network connection, which we call the Y connection as well as the delta connection. So when we have these particular connections, we can use the conversion between the said network connections. But first, let's explore what is a Y-connected network and delta-connected network. So for a Y-connected network, we can see that in 7.4, it is composed of three resistances, say R1, R2, and R3, connected in one end to a common node, say node 0, and the rest of their terminals are connected elsewhere. So makikita natin in figure 7.4 that it can be written in the form of letter Y or it can be written in the form of letter T. So we can actually observe that in the bridge network in 7.3 because we can observe that R4, R3, and R6 are actually connected in Y. So let's try naman looking for the delta connection. So for the delta connection, again, it is composed of three resistances. In the figure shows RA, RB, and RC. It's called delta because it resembles the Greek letter for delta, which is a triangle, no? So makita din natin yan. We can write it in an inverted triangle o kaya in a triangle shape or even in the figure 7.5b that it resembles like a rectangle but has three components. So in this particular connection, we can observe that they should be connected like in a loop. So bawat isa sa kanila ay connected ang kanilang mga terminal sa isa't isa. In the bridge network, as our example, we can observe that as a connection of R2, R3, and R4, and R4, R5, and R6. So if we have all of this, how can we convert this? No? How can we simplify this? You should be able to convert one to the other in order for you to further your simplification. So if you have a Y-connected network, you can convert that to a delta-connected network or vice versa. So kailan natin siya gagamitin? Well, it depends. It depends on the network that we're dealing with. So in order for us to explore the possibility of transforming Y to delta and delta to Y, let us first establish what are the formulas that we can use for this particular setup. No, suppose we have suppose we have a Y connected network. So yun yung gusto nating ma-achieve and we have a given delta. So dito sa ating example, we have a Y connected R1, R2, R3 and we have a delta connected RA, RB, and RC. We'd like to establish a formula that relates each and every one of them, no? So, for example, we are interested in looking for R1, so meaning we are to look for the Y connected out of the delta given. So dito, ang given natin dito would be the RC, this one, the RB, yes, and then the RA. So that would be your given values, and we are to look for your RA, R1, R2, and R3. So how can we solve for R1, R2, and R3? So let's continue. So for R1, based on the books, we can multiply the adjacent values. Okay, so for example, in this case, si R1, ang katabi niya is si RB and RC. So we just have to multiply that. That would be our numerator. and the denominator would be the sum of the resistances in delta. So in other words, that is RA plus RB plus RC. So when we have the value of RB, RC, RA, RB, and RC, we can calculate the equivalent R1 by just using this formula. So again, the numerator should be the product of the adjacent resistances to the one we're looking for. So in this case, that is RB and RC if we're looking for R1, and then divided by the sum of the resistances connected in delta. So similarly, we can solve for R2. That would be RA times RC all over RA plus RB plus RC, because we can note that the adjacent resistances for R2 would be RA and RC. So similarly, for R3, we can calculate it by multiplying RA and RB and then divided it by the sum, because we can observe in the figure that RA and RB are the adjacent sides for our R3. Okay, so now we will proceed to another formula wherein the given is a Y-connected network and we would like to look for a delta equivalent. So in this case, ang given natin would be R1, R2, and R3, and we are looking for the values of RA, RB, and RC. So let's look for RA. So in order for you to do this, you have to multiply the values of the Y-connected network 2 at a time and get the sum of it. So that is R1 times R2 plus R2 times R3 plus R1 times R3. And then divide it by the resistance positioned opposite to the value or to the resistance you're looking for. So in this case, if you are looking for RA, the opposite resistance in the Y network is the R1. So we divide it by R1. Okay, so in summary, again, so the numerator should be the sum of the products taken 2 at a time of the Y-connected network divided by the value of the opposite resistance to the value that you're looking for. So similarly, for RB, we just have to copy the numerator and then divide it by the value of the resistance opposite to RB. So in the figure, the opposite of RB would be R2. So we divide it by R2. So for RC, we just copy again the numerator, which is the R1 times R2 plus R2 times R3 plus R3 times R1 divided by R3, which is the opposite value, opposite resistance to RC. So the 6 formulas established or provided are the formula that you will be using in converting or transforming Y to delta and delta to Y. So suppose we have a network that is balanced. Paano naman natin siya i-convert? But first, we have to define what balance means, no? So a balanced network is defined as a network whose values of the elements are equal. In other words, all elements, say for example, if you are Y-connected, so the values of the 3 resistances should be equal. So say for example, you have Y-connected resistances and we just call it RY, and they are all RY, so they are equal. And we are interested in converting that into a delta, we just call it the R delta equivalent. So we are interested in converting one to the other. So equal sila, no? So balance yung system. So let's recall from our previous presentation that R1 is equal to RA, RB over RA plus RB plus RC. However, since the system is balanced, we say that RA is equal to RB is equal to RC is equal to R delta. So we simply substitute the value of R delta to all elements in the formula and then simplify it. We just cancel the R delta and we have now a equivalent value for R1, which is R delta over 3. Therefore, because of this, we can say that for balanced network, the value of the Y resistance or the resistance connected in Y is simply equal to the delta connection divided by 3, or the delta connection connected resistors or resistances is equal to 3 times the equivalent Y connected network. So this is very useful, especially kapag pare-pareho lang naman ang network natin. So mapapadali ang ating solution. So now, we will proceed to an example. So we will have an example so that we can use the formulas already presented. So for this example, we will calculate the equivalent resistance of a network or a circuit that is that has a Y or delta connection. So let me draw it first. So ito yung gagamitin nating example for this video. Suppose you have this particular network with the following values and with the following nodes, no? So makikita natin dito that it is it is a bridge network similar to the presented kaninang network, and then we have values indicated. So we are interested in solving the R total or R at terminal AB. So how do we do that? So first, i-copy natin yan. And let's say that we are interested in simplifying this by using the Y-connected 8 ohm, 6 ohm, and 4 ohm. And then we would like to convert that to delta. So first, you have to draw the equivalent delta connection. So i-move lang natin, di na nakikita sa screen. So move natin siya dito, yan. So makikita natin that the 6, 8, and the 4 ohm resistors connected in delta, in Y, will be replaced by a delta connected network with Rx, Ry, and Rz. So ang trabaho natin dito is to solve for the values of Rx, Ry, and Rz so that it can replace the 6Y, 6, 8, 4 ohm Y connected network. So first, we have to solve for Rx. So using the formula, sabi natin dito, we just have to multiply the values, okay, of the, since Y connected ito, the formula is to multiply the resistances 2 at a time and get the sum of it. So that is 8 times 6 plus 6 times 4 plus 4 times 8. And divide it by the network opposite to the Rx. So that in this case, that is 4 ohms. And then, we just have to calculate the value of that, and we can get that as 104 all over 4. So the numerator is 104. So simplifying that, we have a value of 26 ohms. So that 104, tandaan natin yan, since similar lang naman ang numerator natin sa lahat, then we can just copy it, no? So we can now solve for Ry. So Ry is simply equal to the numerator, which is 104, divided by the opposite. So, ang opposite niya ay 8. So, ang Ry natin is equal to, that is 13. Okay, so 13 ohms. So, finally, we can now solve for your Rz. So, Rz is again equal to the numerator na 104 divided by the opposite, which is in this case 6 ohm. So, the value now is equal to, the value for Rz is equal to 17.33 ohms. So, once na nakuha na natin yung tatlong values niyan, we can transform or redraw our original circuit, now reflecting the new delta connection. So, we just have to copy that and redraw the whole circuit, no? So, now it will reflect the value or the position of Rx, Ry, and Rz, replacing the original Y-connected network. And now we can observe that we have a progress here. The 4 ohm and the Rx are connected in parallel. The 8 ohm and the Ry are connected also in parallel. And we can observe that actually the combination of those resistances are connected in series in this branch. So therefore, we can easily calculate their equivalent resistance by, we will name it, we will solve it and name it like Ra. So the Ra is simply equal to Rx parallel with 4 ohms plus, because they are in series, with the parallel combination of Ry and 8 ohm. We just have to substitute the values later on and use the formula for parallel and series connection. So we just have to substitute the value of Rx and then the Ry, and then we can use a calculator to solve for Ra. So 4191 ohms. So that is your value. So once that is done, we can redraw again our whole circuit to reflect the value of RA, replacing the complicated network in the middle. And then ang natira na lang sa atin would be the 4 ohm, the RA, and the RZ. So now, we can now observe that this RA and RZ are actually connected in parallel, and their combination is connected in series with the 4 ohms. Therefore, we can already solve for the R total by just adding the 4 to the parallel combination of RA and RZ. We just have to substitute the values of RA and RZ. Then we can calculate the total resistance, which is equal to, the total resistance is equal to 9.67 ohms. So that is now the value of your total resistance. So from the complicated bridge network, we have calculated by using a Y-to-delta transformation that RT is equal to 9.67 ohm. So let's review again the process. So we have this bridge network. We're interested to solve for the R total. So by by transforming the 684 ohm resistance into its equivalent delta connection, we have further simplified the circuit, showing that this time we have a 4 ohm parallel connected with RX, and so on and so forth. And we can further simplify it in solving for the value of 9.67 as our final answer. So that is the process of simplifying our network that contains delta or Y. So this time we will try to explore another solution for this, but this time instead of converting Y to delta, we'll be using a delta to Y connection. If we will observe it in the bridge network, we can see that the 4, 6, 8 ohms sa taas are actually connected in delta. So we will try to transform that into Y, and let's see if we will arrive in the same answer. Okay, so delta to Y ang strategy natin. So the strategy is to just redraw first the Y within the position that we are interested in, and then say that is R1, R2, and R3, and we would like to solve for the values of that, replacing the delta connected 4, 6, and 8 ohm resistors. So let's just do that. So ang isosolve natin dito would be the R1, R2, and R3. So for R1, since we are interested in converting delta to Y, we have to multiply as a numerator the resistance adjacent to your R1. So that would be the 4 ohm and the 6 ohm. So we have 4 ohms times 6 all over the sum, which is 4 plus 6 plus 8. So if we simplify that, we have 24 all over 18. So that would be 1.33 ohms. So similarly, for R2, we can use the 6 ohm and the 8 ohm, which are adjacent to R2. And then the same denominator. So that would be 48 over 18. So that is 2.667 ohms. And finally, your R3 is 4 ohms times 8 ohm all over the sum, which is equal to 1.78 ohms. Now we can redraw the whole circuit, replace the delta connected with a Y connected network of R1, R2, and R3. And then let's see what are the connections now. So R1 can be observed that it is now in series with 8 ohms. And R2 is also in series with the 4 ohm. And the combination is in parallel with each other. So therefore, we can solve for that. We just call it, say, RB. We can call it RB. RB is equal to R1 plus 8. So that is the series on the left. Plus, or in parallel with, the R2 and R4, which also are a series connected on the right. So you just have to substitute the value. That is 1.33 plus 8 parallel with 2.67 plus 4. Okay, so that is 9.33 in parallel with 6.67. So use the formula for parallel connected resistors, and RB will be 3.8889. So that is the value of RB. Now we can redraw once again the connection, replacing the network with RB. And we can now observe that it's a simple circuit, no? It's just a series of 4 ohm, R3, and RB. So we just have to substitute the values of that by adding together. So ang magiging value is 1.77 plus 4 plus 3.889. Then RT is equal to, the total is 9.67 ohms. So that is the same as the previous solution. So we can now observe, or we have proven that we can actually calculate it in two ways. We can calculate it in delta to y or y to delta. It really depends on the network provided. So I hope that you've gained knowledge in simplifying networks that involves Y or delta transformation, Y or delta connection by using the transformation formula or conversion formula from Y to delta and vice versa. So thank you so much for listening, and I hope that you have gained insight today. God bless and goodbye.